The OSI model has 7 layers, which are the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. The data link layer, or layer number 2, is responsible for formatting the packet to be ready for transmission, which is determined by the hardware and the used technology. The technologies include Ethernet, token ring, fiber distributed data interface, and asynchronous transfer mode. However, modern networks mostly use Ethernet. The data link layer contains the protocols that convert the packet into the appropriate frame, which is then sent to the physical layer. Some of the protocols found at the data link layer include the address resolution protocol, the point-to-point protocol, the layer 2 tunneling protocol, and the integrated services digital network. The data link layer also adds source and destination addresses to the frame, and these are the hardware addresses of the physical network interface cards, commonly known as media access control, or the MAC addresses. The MAC address is a 6-byte address written in a hexadecimal notation, where the first half of it represents the vendor of the interface card, known as the organizationally unique identifier, while the second half represents a unique number given to each interface that the vendor makes. The address resolution protocol helps resolve IP addresses into MAC addresses, which allows the data to be forwarded to its right destination. Network devices that function at the data link layer include switches and bridges. The network layer, or layer number 3, is responsible for the routing of data, where it receives the segment for the transport layer and uses it to create a packet. The network layer adds the source and destination IP addresses. The protocols found at this layer include the Routing Information Protocol, the Internet Control Message Protocol, the Border Gateway Protocol, the Network Address Translation Protocol, and the Internet Protocol Security. The network layer is responsible for delivering the information and error detection, but not to guarantee that it has been delivered. Routers are the most common devices that function at the network layer, where they use the network addresses and routing protocols to determine where the packets should be delivered. Layer 3 switches are also devices that function at both the data link and network layers. Routing protocols use either the distance vector or the link state techniques to determine the best path to send the data. Distance vector protocols determine the path based on the list of destination networks and the metrics of direction and distance, while link state protocols maintain and use a topography map to determine the shortest path. The transport layer, or layer 4, is responsible for controlling the communication session and for managing the integrity of a connection. The transport layer receives protocol data units from the session layer and converts it to a segment. It controls how devices on the network are addressed, establishes connections between networking nodes, and defines the rules of a communication session. The session rules include specifying how much data each segment can contain, how to verify the integrity of this data, and how to determine whether the data has been received or lost. These rules are established through the use of a handshaking process between the communicating devices. The transport layer ensures data integrity by providing an end-to-end transport services. The protocols found at this layer include the Transmission Control Protocol, the User Datagram Protocol, the Secure Sockets Layer, and the Transport Layer Security. The session layer, or the 5th layer, is responsible for establishing and terminating communication sessions between devices. It manages the dialogue controls such as simplex or duplex, establishes checkpoints for grouping, and retransmits lost protocol data units. The protocols found at this layer include the network file system, the structured query language, and the remote procedure call.